Okay, so now we have number 10, and number 10 gets trickier because they throw in this ionic compound. And I know that this compound is includes a transition metal because I have these Roman numerals. So if you remember, the first thing that I have to do for this problem, first of all, is find out what the heck this formula looks like, and then I can find the molar mass of it. So if you remember, this Roman numeral has to do tells me the charge of my metal. So vanadium, that's V, has a charge of +1. Oxide refers to oxygen, and oxygen has a charge of -2. It will always have a charge of -2. So oxygen has a charge of 2 -2. To balance out this -2 charge, I need a +2 charge, but I only have a +1 so far. So I'm going to need another vanadium atom. And now I have a total charge of +1 +2 and -2, and now these cancel out and I'm good. So I know that this compound, vanadium 1 oxide, looks like this. 2 atoms of vanadium, 1 atom of oxygen. Now that I know this, I can go and find the molar mass. So the molar mass of vanadium is 50.942. 50.942. But I have 2 atoms of vanadium, so I have to multiply this by 2. So let me do that real quick. 50.942 times 2, because I have 2 atoms, and that is equal to 101.884. Okay, so I have vanadium, I have the mass of vanadium. Now I need the mass of oxygen. So oxygen has a molar mass of 15.999. 15.999. And I only have 1 atom of oxygen, so I can just leave it like that. So now I have to add all of this, find out the molar mass of all of this compound. So I have vanadium and I have oxygen. So now I just need to add 101.884 plus 15.999. And the total molar mass of vanadium 1 oxide is 117.883. And I'm not going to round just because they didn't tell me to. Okay? All right, so now that I know my molar mass of vanadium 1 oxide, I can move on with the problem. They want me to find the grams in 2.3 moles. So I can start creating my little dimensional analysis table. 2.3 moles over 1, just because if you want to see fractions clearly, you can just put them over 1, and it's the same as just saying the whole number, times, I know that at the end of all of this, I want my answer in grams. I'm going to draw a line here. At the end of all of this, I want my answer in grams. So I have to get rid of moles, and to do that, I can put moles at the bottom. So I know that in 1 mole of vanadium 1 oxide, I have 117.883 grams. Remember, grams per mole. So in 1 mole of vanadium 1 oxide, I have 117.883 grams. Now I can just multiply and cancel out my units. So my moles cancel out because they're at the top and the bottom. And all I need to do now is multiply 117.883 times 2.3. And that is 271.13, and I'll leave it there. So my answer for this, there are 271.13 grams in 2.3 moles of vanadium 1 oxide. So first step you have to do, obviously identify the formula. Next step is finding the molar